I'm hoping everyone can see my slides now. Um, my name is Allison Parrish, and this talk is called Computational Stichography, or Connecting Lines. I am an assistant arts professor at New York University in the Interactive Telecommunications / Interactive Media Arts program, and I am overjoyed to be here today. Bang Bang Con is an amazing conference. This is actually my fourth time speaking here, believe it or not, and it is an honor to deliver one of the keynote talks this year. I'm looking forward to luxuriating in the extra time that I have instead of just 10 minutes. So thank you to the organizers and to all the other speakers and to everyone in attendance for helping to carry on this really important event this year. So I'm a computer programmer and a poet, and I'm here today to talk about something that I'm enthusiastic about, which is lines of text in particular. In fact, an interest in lines of text is one of the things that poets and computer programmers have in common. And in this talk, I'm going to share a little bit about why I think the line is so interesting, and then show some of the projects I've been working on that engage with the line as a unit of text. So line one between poets and programmers. The importance of the line to poets may already be clear to you. It's widely understood as the fundamental unit of poetry. As the poet James Longenbach puts it, poetry is the sound of language organized in lines. More than meter, more than rhyme, line is what distinguishes our experience of poetry as poetry rather than some other kind of writing. Poets make use of the line in a remarkable variety of ways. Just a few examples: Emily Dickinson's lines that carefully interweave rhyme, clause, and punctuation; William Carlos Williams' lines that have tense and dramatic enjambment that break syntax across lines; Nerbese Phillips' near ejection of the line altogether in favor of more free and expressive layout in song. You can make rough taxonomies of how poets use the line, but no formalism can entirely capture all of these techniques. Just as a quick review of terminology so I don't lose some of you, the word that poets use for the way that a poem is divided into lines is called lineation. Frustratingly, this is also a term of art in geology, so whenever you search the library database for lineation, you get a lot of results about sandstone. Another common term is enjambment, which is a technique for lineation that involves introducing line breaks in unexpected places, like in the middle of a sentence or the middle of a word. While researching this talk, I discovered from the Oxford English Dictionary that you can also say this word in a fancy French way, enjambment, which is a nice way to feel learned and important, so I might say it that way for the rest of the talk. Programming isn't all about lines the way that poetry is, but programmers do deal with lines a lot in their course of work. The line is, of course, an important mathematical abstraction used in both computer graphics and statistics, but the line as a unit of text is actually equally important to computer programming. Code is conventionally written in plain text files, which are sequences of characters delimited with the line break character. Version control software like Git uses the line as the atomic unit of change. When you apply a patch to a file with Git, you're applying that patch based on lines of text, not some other unit like characters or bytes or functions or parts of a syntax tree or anything like that. Dozens of Unix data processing tools like grep, sort, head, tail, cut, all use lines as their fundamental unit of processing. So poets, programmers have in common this interest in the line as a unit of text. Line number two, ASCII and Stegometry. But code isn't the only part of programming where the line pops up. The line is also the go-to unit for organizing data. Many file formats, both official and ad hoc, make use of the line break, the ASCII line feed character, as a record delimiter. This is, on the slide you see an example of data in CSV format in which the data is stored in a plain text file, and each datum, each line of data, is stored as an individual line. The line feed character is arguably the most popular way to delimit records in data, despite the fact that the ASCII standard actually has included from its inception a control code specifically set aside for separating records, hexadecimal 1E, the record separator control code, which I've highlighted in this list on this slide. But nobody actually uses that record separator control code to separate records. And I think a reason that people use the line feed character instead is instead, even when there's this like tool that's been set apart specifically for that purpose, not like ambiguously the way that the line feed character is. The reason that I think that's the case is that the spatial metaphor of the line is just too well established. Like we already think about data in terms of lines, so it's difficult to resist using the line feed character for that purpose. The visual line, as much on a sheet of paper as on a computer screen, is already used everywhere as a way of organizing information. The convention of having rows of data arranged vertically from top to bottom by time dates back to pen and paper ledgers, and even as far back as ancient Mesopotamia. There's on the right there, you see a cuneiform tablet that's showing tabular data from 1295 BCE that looks exactly like a spreadsheet. And arguably, maybe it even goes back to the origin of writing itself. So the line break is already a record separator. We didn't really need a separate character for that. Lines are a way of organizing information, but they're also likely the earliest unit used to measure text itself. Ancient Greek scribes divided text up into lines and then counted those lines up in order to better catalog text and to make it possible to refer to sections of text by their parts, sort of the original page number. And of course, that would be useful with scrolls where there aren't pages. This process of counting lines is called stigometry, from the ancient Greek stikos, which means a row of soldiers or a line of poetry. One scholar I read argues that the stigometry was the birth of text analysis and corpus linguistics, saying that segmentation of text into formal semantic and later syntactic units not related to the physical data carrier was at that time a great achievement and allowed future generations of philologists and grammarians to create the first real corpus and statistical tools, by which I mean concordances and indexes. So the line may have been like the beginning of being able to do statistical analysis of text that leads us to things like TF-IDF and things like that today. The photograph in the slide shows a line number in the margin of a manuscript copy of a text by Plato. That's from the 9th century. In ancient Greece and medieval Europe, books were often cataloged by name and line count, and book buyers used the line counts to ensure that the copies they were buying were complete, sort of an ancient checksum technique. The image on the left is a list of books in the Codex Claromontanus from the 5th or 6th centuries CE, Common Era, in which the titles of various Christian texts are listed next to the number of lines in the corresponding text in Roman numerals. To me, this looks a lot like the output of the Unix word count command, WC-L, with the line count option enabled. So stigometry is alive and well in the 21st century on the command line. Another interesting, fun parallelism between ancient scribes and computer programmers is that, according to this often cited paper by J. Rendell Harris, scribes in ancient Rome were paid by the line, and also programmers, of course, their productivity has in the past been evaluated based on the number of lines of code that they write. And the image just shows a paper that I found about using lines of code as a productivity metric. Lines are one of the ways that language becomes data, and wherever you have data, money isn't far behind. Next line is between linen and cannabis. Earlier, I mentioned the etymology of the ancient Greek word for line, stikos, which also is the word for a row of soldiers. And that actually comes from the same Indo-European root that gives us the English word for stairs, because you're walking up them, you're climbing up them. In an alternate reality, the word for line, poetry in English might have been a stair of poetry, which I think is interesting. But the word for line in English ultimately derives from the word for the flax plant, which produces a fiber that remains rigid without having to be held taut, like other fibers need to be. That is, a flax fiber is on its own a straight line. To me, this etymology of the line explains the main metaphorical difference between a line and, say, a rope, a cord, or a string. Straightness in nature is the exception and not the rule. A rope, a cord, or a string becomes a line when someone holds it taut and rigid, like a linen fiber, thereby removing the slack. Likewise, with the ancient Greek word, a row of soldiers stays in formation only through discipline. You have to exert effort in order to keep the line straight. In computer programming, we use both the words line and string to refer to sequences of characters, but they're not interchangeable, and I think there's a reason that we call it the command line and not the command string. A string can contain an arbitrary sequence of characters, but a line is text that has already been set apart as having some intention, a record in a file, or user input in response to a prompt, or something like that. While I'm on the topic of etymology, one of my favorite topics, I'll point out that the English word read originates from a word that means govern or counsel. The word file comes from the Latin word for thread. So a fair etymological and metaphorical translation of reading a line from a file is governing a thread by pulling it taut. One more etymological aside, just as the word line comes from the word for flax, the word canvas is cognate with the word cannabis, a plant whose fibers are often used to make durable fabric. So the next time you are using JavaScript, say, to put a line on a canvas, you can think of it as like gently setting a flax plant on top of a cannabis plant, which I think is a nice image. The next line that I want to draw is between oxen and typewriters. Getting back to literature and writing more specifically, in the history of the written word, you can actually distinguish two different kinds of line, the graphic line and the poetic line. The poetic line is also called a verse. A graphic line is just what you call on a writing surface when you see a number of glyphs placed in sequence, sharing the same baseline as they progress across the writing surface. In some writing systems, glyphs and lines are arranged from left to right, in others from right to left, in others still top to bottom, and then moving across the page from right to left or left to right. This image shows an inscription on a fragment of stone plate in archaic Cretan script written in Boustrophedon style, in which characters and lines alternate between being arranged from left to right and right to left. And you can actually see that the orientation of the characters change as the writing progressed from the top to the bottom. Boustrophedon means in the manner of oxen plowing, because you get to the end of one row and then you move back to the next, starting from where you were. The graphic line, I think, originates just as kind of like a side effect of the need to adapt media of different dimensionality to each other. We tend to perceive speech as a one-dimensional medium, a sequence of sounds and words. Most writing surfaces, on the other hand, are understood to be two-dimensional. So when you're writing speech onto a writing surface, like a scroll or a sheet of paper, you have to find some way to fold the one-dimensional sequence onto the two-dimensional surface in as efficient a manner as possible. And that's what a line is. It's a way of like folding one-dimensional data onto a two-dimensional surface. In this slide, I'm showing a Hilbert curve as an example of another way to fill a 2D surface with a line. No writing system that I'm aware of uses Hilbert curves to lay out text on a page, but I think it would be cool if there was one that did do that. In purely oral literature, by which I mean literature that isn't written down, poetry also has lines. In this case, usually where a line ends is determined not by space limitations of the writing surface, of course, but by metrical, phonetic, syntactic, and semantic characteristics of the words themselves. What's interesting to me is that when poems from the oral tradition were first written down in antiquity and in the Middle Ages in Europe, for example, apparently there was no consensus that one poetic line should correspond to one graphic line. Instead, you see a variety of conventions for separating poetic lines in manuscripts, including things like placing a point after the last word in a verse, putting spaces in line between verses. We'll see an example of that later, or using capital letters at the beginning of each verse. Catherine O'Brien O'Keefe points out that the technique of starting verses flush with the left margin and leaving blank space up to the right margin for a single verse was maybe used only as a last resort in medieval manuscripts because it was a waste of the expensive writing material, leaving all of that expensive, expensive vellum, you're leaving it blank. So that thing that we think of as being the usual way that lines of text are written, especially lines of poetry are written, where you have one graphic line per poetic line, is actually like, not the only way that you do it, and it's kind of something that's only become the standard in a contemporary modern context. In fact, we still use graphical conventions like putting a point after the last word in a verse when we use the slash character to separate lines in poems or lyrics when you're quoting a poem or a song in line in prose. Um, as far as I can tell, it wasn't until centuries later that the conflation of the poetic line with the graphic line became as universal as it is today. And I might argue that the conflation was only truly complete after the invention of the typewriter, a technology that allowed poets to essentially typeset their own texts and quickly experiment with how lineation affected the process of reading and composing poetry. The poet Charles Olson, in his well-known 1950s manifesto, Projective Verse, basically claims this and says, the line is equated with the breath, and the typewriter is the first technology that the poet has had that allows them to indicate their breath as precisely as they want to on the written page. The next line is between tidiness and fleshiness. So taking all of that into account, we've seen the line in many different forms and contexts. So what makes the line such a powerful and persistent unit of organization in text? On this question, I think the poets themselves have some good answers. The most elegant formulation about the line I've come across in my reading and research comes from the poet Lynn Heginian, who writes, "The line affixes detail to time. The writing of the line begins as an act of observation, and it is completed by recognition of the thought that it achieves there." I understand this to mean that in the process of translating sequences to surfaces, the line is how a writer notes detail in anticipation of how the reader will approach and perceive the text as it unfolds in real time in the process of reading. The line is how a writer draws attention to particular characteristics, or in Heginian's terms, particular observations of the language in question and how it operates. The poet and scholar Johanna Drucker emphasizes not the temporal aspect of lines in time, but instead their visual and spatial aspect. She writes, as visual forms, the lines create their own order in the text, a frame which introduces the struggle of hierarchy into the words. The breaks become a force against which the whole must be recovered, or against which the whole can be fractured, dissolved, let go. The visual line strains the literary authority with its vulgarity, its crudeness, its fleshiness, which pollutes the material of pure language. Drucker is arguing here that the spatial layout of text on the page has its own significance, which demonstrates that written language is never simply a straightforward transcription of speech, but something more that has its own affordances and operates with its own conventions. In other words, a text always carries traces of the fleshy physical world with it. Not just the decisions that the writer made in adapting language to the visual form, but also the material of the page and the physical gestures of the writing process, whether that means the writer's penmanship or their keystrokes or any of the other things that go into producing a physical text. Finally, Ron Silliman, the poet Ron Silliman, wrote this, which I think is important for talking about the line as it regards computer programming. The line is the sole unit of punctuation whose use historically has not been determined by its potential for submitting chains of words to the hierarchic orders of logic, descended from the classical grammars of Greek and Latin, which have become our normative contemporary model for clarity in writing. In other words, one role of the line is specifically to cut across grammar and syntax, especially when grammar and syntax alone don't give us the expressive tools to do what we need to do with the text. All of these statements about the use and lineation of poetry apply equally to the use of lineation in computer programming. Most programming languages understand their input as just an unbroken stream of tokens from which any characters representing visual layout, like spaces, tabs, and line breaks, are stripped before the program is compiled or interpreted. Nevertheless, programmers make use of visual layout in their source code, and line breaks in particular, in order, I think, to affix detail to time. and make the source code more readable for themselves and for other programmers. What's considered readable code is, however, highly conventionalized and often algorithmically enforced with tools like linters and autocomplete. In this animation, I'm using the P5.js web editor to make this creatively formatted code more tidy, in the word of the editor. In my experience as a programmer, and maybe in your experience, I've found that not all code is made more readable by adhering to convention, and sometimes there are bits of code that require unconventional lineation in order to make their inner workings more evident. Sometimes, as a programmer, you have to enjamb your code. And many programmers also know that readability can be an arbitrary concern, which is among the reasons that the International Obfuscated C Code contest exists, in which contestants often make use of line breaks and layout towards more aesthetic ends. This is Edward Giles' entry from the 2019 competition that has little waves. The code is broken up into these little waves, which I think is nice. It actually is a program that applies reverb to a wave file. Even in a language like Python, which is somewhat unusual by virtue of the fact that white space is actually a part of the language's syntax, Python still provides so many resources for creativity and expression with line breaks that entire PEPs have to be written in order to guide people in the right way to do things. As with other languages, there's even a module, probably many different modules for automatically reformatting your code in order to conform to these conventional standards. Personally, as a poet and a Python programmer, I would never use one of these libraries because I have too much fun playing with the layout and making the layout do exactly what I want it to do inside of a Python program. So that's some historical background. With that in mind, I want to talk, and speaking about Python programming, I want to show off some of the stuff I've been working on recently that concerns lines of poetry. As a poet, I've been interested in putting the idea of lines as freestanding textual units to the test, removing lines of poetry from the original context and then figuring out ways to juxtapose them in unusual ways. This sort of line of research started a few years ago when I made something that I call the Gutenberg poetry corpus. That corpus consists of around 3 million lines of poetry generated from Project Gutenberg, which is a database of texts that are in the public domain, around like 70,000 books that are in public domain, that are all available in plain text format that makes them really easy to manipulate for text analysis and creative purposes. To build the Gutenberg poetry corpus, I wrote a program that goes through all of the metadata in Project Gutenberg, finds all the books that are listed as poetry, and then I scan through those. My program scans through them line by line, extracts line of text that look like poetry, as opposed to introductions or commentary or footnotes or other paratexts, and then collect them together, and it ends up being a 52 megabyte file that contains 3 million lines of poetry from all of the included books in Project Gutenberg, or at least the books that were in Project Gutenberg a couple of years ago, along with a number that identifies the volume that it originates from. This is actually stored in JSON format, but the particular kind of JSON format where you separate JSON records with a new line, which I don't even know if that format, it's used all over the place, but I don't know if it has an official name. This is a diagram of the process of creating that corpus. The most sophisticated part of the code is the rules to determine what counts as poetry, which is just a bunch of ad hoc criteria that I'd eventually like to replace with something more well-reasoned. But this program works pretty well and does what I want it to do. The corpus, just to give you an idea of what it looks like, this is an animation of what happens when you make a program that just prints out lines at random. So it's just like a big stream of lines of poetry that have been taken out of their context. Actually, the reason that I made the Gutenberg poetry corpus in the first place was because I was teaching a creative writing class in 2015, and I wanted to give my students an assignment to write autocomplete poetry, which is usually you go to Google and you type in some words and then you make a poem from what Google suggests after what you typed. But I didn't want my students to have to use Google to do this if they didn't want to. So I made a quick tool with Nginx and Redis that sort of works like Google Search Autocomplete, except it autocompletes your typing with a line of poetry from the Project Gutenberg poetry corpus that starts with the same letter. So you can search through it and it completes it with the line that matches that prefix. This is actually, I believe, still online. It's 5 years old, which is an eternity in online art project terms, but I think you can still go there and use it. Once I had that corpus, other applications started to suggest themselves. The poetic line, as we've discussed, is often determined by sound, meter, rhyme, assonance, alliteration. These are things that like set one line of verse set apart one line of verse from another. Starting with this insight, I wanted to make a project that could sort, cluster, and juxtapose poetic lines based on their phonetic characteristics. Basically, what I wanted to do was, first of all, find a way to represent the sound of words as vectors so that I could draw like a scatter plot like this, where words with similar sounds like octopus and apocalypse would be closer together on the scatter plot, and words that are dissimilar like inky and kinky would be further away, even though they would be clustered together. So finding a way to like turn a word, the phonetic information of a word into a vector. To do this, I made a program using the CMU Pronouncing Dictionary, which is a database of English words and their pronunciations, which you need in English because the way that words are spelled doesn't really have much with how they sound. And then I wrote sort of like a weird kind of ad hoc feature detection manual feature extraction algorithm that uses bigrams of phonetic features in order to produce a big matrix of counts of features, used principal components analysis so that I ended up, for every word of English, a single 50-dimensional vector that represents the sound of that word. I use that same algorithm then to get a 50-dimensional vector for every line of poetry in the Project Gutenberg corpus. So for every line of poetry, I had a number, a coordinate in space that indicated the sound of that poem. And with that, I made this book called Articulations. This is a book of computer-generated poetry. It was published by Counterpath Press 2 years ago as part of Nick Montfort's Using Electricity series, which consists all of the books in the series are computer-generated. And I've included an example of the output here. I don't have time to read it, even though I love reading it. So the book is composed of an automated random walk through the phonetic space of the Project Gutenberg poetry corpus. I start with a random line of poetry, and then I find the line that is most phonetically similar to it based on its calculated vector, and then add that to the output, find the line that's most phonetically similar to that, add that to the output, and so forth, excluding any line that has previously been in the output. The end result is this kind of poetry where cohesion is achieved only through phonetic similarity. And one key decision here that has to do with the topic of this talk is that I decided to format the output as prose by running the lines together into paragraphs instead of retaining the original formatting of the lines. And my reason for doing that is I wanted to blur the distinction between lines and draw attention to how they're similar to each other. So that's one experiment with that corpus. A more recent project, which I'm calling Variational Cestinoid Spirals. This is less about the sound of words and more about the meaning and syntax of lines of poetry, and the ways that machine learning can facilitate the invention of new poetic forms. Computer-generated poetry, of course, is a whole field of practice in computational creativity. You can get on Google Scholar and find, hundreds of papers about generating poems with computers. But the question I started out with was not how do I generate new poems, but how do I generate new lines of poetry? How do I make a generator that knows how to produce just a single line of poetry? What does it mean to write a generator that produces a single line? To do this, I made use of a kind of neural network architecture called a variational autoencoder, sort of akin to a GAN, in the sense that it is a model that kind of essentially learns how to compress data. The encoder produces a fixed length vector for each item in the training set, and then the decoder learns how to produce the original data from that fixed length vector. In a variational autoencoder, the values in the fixed length vector are constrained to conform to a particular statistical distribution. And the benefit of this is that the model becomes generative. You can generate new data that looks like the original data by picking random numbers and feeding them to the decoder. Similar random numbers produce similar outputs, and you end up with a latent space that can be explored. This like the coming up with the idea, I did not invent the idea of a variational autoencoder, and I'm only a beginner machine learning engineer, so I relied very heavily on the research from these researchers, from Junshen He and Benjamin Heinzerling's pre-trained embeddings for byte pairs were also a big part of this project. I should also note that I was like super inspired by Robin Sloan's sentence space project from a couple of years ago, which you'd look at. And I have a link to my fork of the variational autoencoder code that you can actually launch in a Jupyter Notebook in your browser if you want. So once you train this model, you end up with a model where you can feed a random number into the decoder and get back a line of poetry. Part of the reason that I wanted to do this was to be able to explore poetry space. Last summer, Runway funded my work on this model, and part of the reason that I wanted to make it so that I could use their latent space explorer in the Runway app. What you're seeing here is like a single sample from that space surrounded by samples that are from similar numbers, and you can sort of move over it like Google Maps. So each box contains a line of poetry that is generated by the model from nearby points in that latent space. Once you have a model like this, there's all kinds of fun stuff that you can do. One is creating interpolations between two different lines of poetry. So you encode one line of poetry and encode another line of poetry, and then decode from points along the line that connects them, the line that connects them. So this is an interpolation from the first line to the last line of Robert Frost's The Road Not Taken, taking a more direct road from the beginning to the end of this poem. So this is sort of like the result of drawing a line through a latent space of lines. It's like a meta line in a sense. When I showed this project on Mastodon, a user there suggested circular interpolations, meaning pick a random hyperplane and then decode from a circle drawn in the hyperplane. And using this technique, you get lovely lines of poetry that seem to return to where they started. And it's just a little interface I made in P5.js to explore one of these circular interpolations. The poetry generator that I made with this technique produces poems by sampling lines from points on concentric circles that gradually increase in size in the latent space. It follows a schematic that looks like this. Each circle represents a stanza, and as the circles get bigger, the stanzas get longer. In essence, each stanza is an elaboration on the last. I might read just a little bit from this one. This is a moment, that is a moment, full of a moment could be seen, that is made, that shows a moment, having been pure as a little heart was seen. That is made, that shows a moment, having been full of a moment, still had seen her eyes, making a little heart of man. The present, that shows himself, however, that space of moment had been gone, and sweet as a smile of beauty's eyes, praise to my heart. The present that shows perhaps the latter of this moment, having been as sweet as thou shalt have seen his eyes. Sweet a mile of my heart is bright, only the heart. The latter that shows perhaps the books of being, having been for such a different hours had passed, and all shuddering with her fair eyes of her eyes. Sweet a smile of my dear face, seeing the word, that is a moment. Which I like. I think that's a pretty good result. All of this finally brings me back to the title of the talk, computational stichography. So making that poetry variational autoencoder was fun, but at this point I've made so many projects with the Gutenberg poetry corpus that I'm getting kind of sick of it. Because it consists of poetry in the public domain, specifically in the public domain in the United States, it mostly consists of 18th and 19th century white male American and British poets whose poetics, by and large, let's say, are not especially expansive in subject matter or style. So a lot of what comes out of the variational model has a pretty monotonous diction. It all sort of sounds like a mishmash of Coleridge and Wordsworth, like falling asleep in your high school English class. So I could just make another corpus, you may say, but the issue is that this is the only corpus of poetry that I know of that is both freely available and entirely unencumbered by copyright. I could scrape the web or scans of books for contemporary poetry, but then I wouldn't feel like I had any real ownership in the output of the program, and I'd be obligated to seek out the permission of every poet whose work was used to train the model, and I don't have time for that. So the solution I'm pursuing is to find some way to introduce poetic line breaks into arbitrary text. That way I can use any kind of text to train or at least fine tune the model that I made. Um, and if I wanted to, I could train a variational autoencoder to produce lines of poetry about flowers by grabbing all of the Wikipedia pages about flowers, splitting that prose into lines, and then use those lines to train the model, and then publish the resulting poems under the same license as Wikipedia. So I've made some progress on this, and I want to show you that progress. Um, I'm using this word stichography to describe the process of adding poetic line breaks to arbitrary text. Um, that term comes from biblical studies, where scholars use it to describe how scribes copied certain poetic or musical passages in scripture, not in the regular continuous script, but with graphic devices to separate poetic lines, like spaces or line breaks between the verses. Um, Showing here an example of the same passage from two different scrolls, one in which the scribe has copied the passage in continuous script, and another in which the scribe has written the passage in a stichographic fashion, with the blank spaces to note the ends of poetic lines. These are written in line. These aren't line breaks. The lines are separated by spaces. The scroll fragment isn't from the same passage, but it shows what the empty spaces looked like in the original manuscript. So as I understand it, different scribes had different techniques for writing these passages stichographically. They applied a set of criteria to determine which passages should be written stichographically, but came up with their own strategies for performing the stichography based on their own ideas about how the text worked phonetically, semantically, syntactically. So what I need is to be able to do what these scribes did, but in an automated fashion, so I can do it on, thousands and thousands of Wikipedia pages. So I trained a machine learning model to do it. I treated this as a sequence prediction task. The input to the model is sequences of tokens from the Gutenberg poetry corpus. And the labels are either a 0 or a 1, with a 1 indicating that there should be a line break directly following that token. My theory is that most lineation relies on the sounds of words. So I used Pencilate to find phonetic embeddings for each word instead of using just like numerical indexes in a vocabulary. Pencilate, by the way, is the grapheme to phoneme model that I actually talked about in my Bang Bang Con talk last year. I think that using the phonetic embeddings makes the model more accurate. And it also makes it possible for the model to deal with out of vocabulary words or even like made up nonsense words, which is definitely a benefit. The network architecture is a stack of bidirectional recurrent neural networks. I know that everyone has moved on to transformers or whatever, but it took me like 2 years to understand RNNs well enough to be able to just like whip up a model like this on a whim. And I am planning to make the most of that investment. And I'm still working on this. But my little test models accomplished the task that I wanted to do pretty well, achieving 93% accuracy on my validation set after training on my 2013 MacBook Air overnight, which isn't bad. I only like to make neural network models when I can train them on my laptop. So this is a video of a live typing interface that I made with an early version of the model. You type continuous text on the left there and get back text with the model's stichography applied on the right. The model does pretty well with these two light nonsense poems. Neither of these were in the training set. I never saw a purple cow and never hope to see one, but I can tell you anyhow, I'd rather see than be one. I eat my peas with honey. I've done it all my life. It makes the peas taste funny, but keeps them on the knife. So it does pretty well actually in finding reasonable line breaks in this text. As another proof of concept, this is some of the text from the Wikipedia page for zinnia, the flower zinnia, with the original continuous text there on the left and the model's stichographic output on the right. I think this is actually pretty good if you read over it. I think it's finding like, places to break the text that sort of fall in line with your expectations about where line breaks should go in poetry. I haven't actually used this to retrain my variational model yet, but that's the next step. So this is still a work in progress. So to conclude, what draws me to the line as a unit of language is that it's really the interface between language and the world. The line is language held taut, and someone has to be doing the work of holding it taut. So whether the line we're talking about is a poetic line based on rhyme and meter, or a line in a spreadsheet recording a single data point, or the line of code carefully crafted to elucidate or obfuscate the inner workings of a computer program, the line demonstrates that language is, in Johanna Drucker's words, fleshy. Language is always situated in physical and social reality. And that is my talk. Thank you.